Recording here. Hi folks. So you'll probably notice that you can see through my shirt. You'll be able to see it later. You can see the date through my shirt. I did the dumb thing of wearing a green shirt when I'm teaching in front of a green screen. You knew it was going to happen eventually. So you all can make fun of me all class. Last class decided that I was a ghost, that I wasn't actually real. That I don't exist. That's true. None of your professors actually exist. We're all ghosts. Yes, it is very spoopy. Maximus in Twitch chat asks how I'm doing. I'm fine, other than that I'm a ghost. How does grading work? Is it check, letter, or number based? We will give you a number on each thing that you do. It's going to be like 1 to 5 for your labs, 1 to 5 for your projects, and 1 to 10 for your other work, for your papers. Okay, we got another question. Why is it that when you take pictures of the moon with your camera, they seem a lot smaller than when you're looking at it with your eyes? If you mean your cell phone camera, it's because your cell phone camera sees a wider view than your eyeballs do. So, if I pick up this camera, so I'm pointing it at one of the lights in our studio, right? I can zoom in on these lights. Your cell phone camera sees an angle of view that's about like this. Its lens is about 28 millimeters equivalent. See an angle of view that's like this. It's about 50 millimeters equivalent. This lens I can zoom in to 70, and other lenses go much, much narrower. So the reason that it looks very small in your cell phone pictures is in part because the angle of view your cell phone sees is smaller compared to the, or is wider rather, than the angle of view that your eyeballs see. That's not what I want. Let me now fix the angle of the projection here. There we go. You didn't do last week's lab until yesterday. Will you still get credit? If you had a good reason, yes. Talk to us about that. Yes, for other groups, you are not giving a numeric grade. You're simply giving comments. We will take those comments into account when we do give a numeric grade, but we're not asking students to grade anyone else's work. We're just asking students to evaluate it. We will do the grading. Everyone in the group should get together. You should submit one thing. So a question from Twitch. Does every group member have to do the peer group evaluation or just one per group? You should all get together. You should all talk. And then you should submit one evaluation. So people are asking lots of questions. I have a slide for questions here. Kirsten says, you haven't heard from your third partner, nor have you received the project you're supposed to evaluate yet. If you haven't heard from your third partner, then that is their issue. So a lot of people have been asking things like, what happens if I haven't gotten the thing I'm supposed to evaluate? So if your group has not gotten the thing you're supposed to evaluate, then you should probably ping that group and say, hey, you should send me your work. So let me show you an example. So we're going to go to, so here is the evaluation page. So Kirsten, so here is your thing. Kirsten, actually, I recognize this third name. I'll talk to you later about what's going on there. So what Kirsten points out is this says you're evaluating these people, but you didn't get anything from them. Oh, okay. So Kirsten, what happened for you then is if they sent it to a different group, what that means is that, remember the evaluation pairings changed because of all of the group flips we had to do in the first week? So if they sent it to a different group, then you don't have to do anything, right? If they send it to a different group, you're fine. So you and Andrew can chill. But otherwise, if that didn't happen, so you contacted them, you did the right thing. But if you haven't heard from the group that was supposed to send you their work, then you should contact them and say, hey, could you send me your work? And then if you never get anything from them and they just ditch you, then that's their problem, not yours. A thing about working with your groups. So everybody in this class is an adult, and if you have issues with your group mates, if they have not written you back, or if they are sick, or if something like that happens, then you should respond to those things in an adult way. We've gotten some messages saying, you know, such and such in my group is not working well with us. Please give them until talk to them and say, hey, there's this problem. For us, Shahilia, one of our TAs, is kind of taking the lead on dealing with group issues if people need to be reassigned. So email AST101 and copy Faraz on it. I see people talking in Twitch chat. Talk to them and say, hey, you know, we need to work together here. And if you continue to have problems through Lab 2, we will get you a new group. I've gotten some messages like that. It takes time to deal with those just because we want to understand what's happening. But don't worry, we will get those things fixed if you all continue to have issues with people in your groups. So Lab 2, Hamelin asks, Lab 2 is due when you do Lab 2. So everybody's doing their second lab on the moon this week. If you don't finish during the lab period, we'd like you to finish up within 2 days and send it in. That's Lab 2. The second project is, I'm going to assign it right after class today. So there was a request for me to do office hours today. So as soon as I get out of here, as soon as class is done, I'm going to go sit on the steps of Hendricks Chapel and push all the buttons I need to push to post Project 2. I've already got it written, I just have to post it. You can ask me other stuff if you want to come at that point too. But that project will be due before class next Thursday. So you'll have a week and 2 days to do it. There are two variants as always. One of them asks you to plan a night sky photograph involving two people who are going to get married. And they want a picture of themselves with the Milky Way behind them, and you've got to plan that. The other one involves changing something about Earth's rotation and coming up with that as the basis of a science fiction story. I don't know what Uzma means in Twitch chat. Someone will have to explain that one to me. So for the people on Zoom, what am I talking about? So on Twitch, there are little emoji, basically, that all mean stuff, but you don't know what they mean unless you know the memes. And I know some of them, but I don't know others. The whole narrative is given to you in the project. No, there will be different evaluators, and I will tell you what those are. I'm not going to post them yet because I want to do the group changes yet, but don't worry, you'll have all the information you need by the time you need it. So the way the rhythm will work is your groups will be the same, except for the people who've asked for changes, and then before next Thursday, I will tell you who the evaluators are. But I want to get as many groups fixed as possible before I roll the dice, because I have a computer program that randomizes who does what. So, we are here to talk about the moon and the sun and all of those things, but is there any other astronomical object people want to talk about before we get back to the moon and the sun and the Earth? Oh, Zoom chat is broken, someone says. Let's fix Zoom chat. So why is Zoom chat broken? Zoom chat is now unbroken. Thank you. As always, if there is ever anything wrong with the AV, please just let me know. I am one person doing a lot of things. I make tons of mistakes, and I'll fix them as soon as you tell me. Comets are cool, but life on Venus is way cooler. So what happened on Venus? What are we talking about? Yeah, possible life on Venus. So, what's the deal? Did we find aliens on Venus? Did we find something else on Venus? So, I'm getting Windows out of the way here. They found a gas that suggests possible life. There were traces of a kind of gas that supports life. It doesn't support life. We think it's a byproduct of life. We think it's a gas produced by microbes. And on Earth, when we find phosphine gas, it is typically a sign that there were microbes producing this gas. So I want to talk about a couple of things. First, what is Venus? What is Venus like? What are the conditions on Venus like? What are the conditions required to have life? And how was this discovery made? How do we know there is phosphine on Venus? And what does it mean? So let's start with a comment from Twitch chat. What are the conditions on Venus like? They are terrifying. I've taught this class for a number of years, and sometimes I reuse the slides from a previous year here and there. I like Mr. Potato Head my slides together. I'm doing less of that this year because we're online. But in a previous year, I mentioned something that Venus was basically hell. It rains sulfuric acid. It is so acidic on Venus that the normal ways that chemists use to define pH don't work. But on another scale, Venus is 100 billion times more acidic than concentrated sulfur, well, 1 billion times more acidic than concentrated sulfuric acid solutions here on Earth. So sulfuric acid rain, hot enough to melt lead on the surface, and atmospheric pressure that is almost 100 times as strong as Earth's. So Venus is hell in the solar system. But we know on Earth that life can survive in all kinds of different places. Kirsten, what is All Summer in a Day? I don't know that book. Emma asks, do I think Venus is a view into Earth's future? You're probably thinking that the conditions on Venus, the extreme pressure and heat, are caused by a runaway greenhouse effect. So the greenhouse effect, which we will study at length later in our class, is the tendency of certain gases, like carbon dioxide, in the atmosphere to redirect energy back down to the surface. We'll study that a lot later. But the short version is that Venus's greenhouse effect is far stronger than anything that Earth probably can produce. So it is unlikely that, so humans causing climate change, we may change our climate into what the climate at the time of the dinosaurs was like, but it's very, very, very unlikely that we will change the climate on Earth into something like Venus. It's funny, it is still Earth's twin in that it is closest to Earth in size, and it's closest to us in position in the solar system. But other than that, our planets are very, very, very different. A question about coronavirus surviving there. Coronavirus absolutely could not survive on the surface of Venus. It is so hot that organic molecules made out of long chains of carbon atoms, which is what comprises life, would fall apart. So that kind of temperature, you couldn't have viable viruses there. So Kirsten mentions that there's this short story on Venus where you get, for some reason which I don't know, only one day when you don't get sulfuric acid rain. I want to talk about science fiction for a bit. This is not so much of a digression, but it's an allusion to your second project. So your second project, one of the two that you might have to do is to change something about Earth and then dream up a science fiction story based on the thing you changed. And the basis of a lot of really, really, really good science fiction is change something about how the world works, keep other things realistic, and then think carefully about the consequences. In-person class on Venus. I'll stick to Syracuse being cold rather than 900 Fahrenheit on the surface. I can deal with the snow. So that's what Venus is like. And on Earth, we've seen life survive on Earth in all kinds of different conditions. We find life at 7,000 meters above sea level on Mount Everest. We've found life in temperatures above 100 Celsius at the bottom of the ocean in thermal vents. We found life in incredibly strong acid, but not as strong as on Venus. But there's one thing on Earth that all life has in common, a thing on Earth that every living thing needs. What is that? So people are saying oxygen. Let's talk about oxygen for a minute. Molecules containing oxygen, yes, but like oxygen that you breathe, would you believe that's poisonous to many living things? Oxygen was the first air pollution. It didn't kill the dinosaurs, but it killed a lot of other ancient organisms. So oxygen was air pollution. It's produced by plants as a byproduct of their metabolism. And oxygen is super reactive. I used to live near where they developed rocket engines. And I'll tell you that story later in the semester. I grew up listening to them test the space shuttle engines. And there is a giant hole in that NASA facility where an oxygen tank blew up and they left the hole there as a way to remind people to respect oxygen. It is incredibly reactive. Not Area 51, Marshall Space Flight Center in Huntsville, Alabama. And because oxygen is so reactive, only organisms that are specially designed to deal with oxygen aren't killed by it. And there weren't any of those in the beginning. So the plants produced all this oxygen, the very first photosynthesizing organisms, and then a bunch of other stuff died because it couldn't deal with oxygen. Many of those organisms, bacteria, still live deep underground where there isn't any oxygen. The rest of us say, oh, well, if the plants are going to make this stuff, we might as well use it. And now we can't live without it. Alex has said carbon. Yes. Living things have molecules, large molecules, that use carbon chains as their backbones. That's what life is made of. If someone asks you, what's life made of? The one-word answer is carbon. But a bunch of folks are saying water. And that's the other thing that all living things on Earth need, is liquid water. Because what life is are long carbon chain molecules dissolved in water. So that means that the only places you could find life on Venus are places where you've got liquid water. If it's like life on Earth, could have things that are very different, but if it's like life on Earth, you need liquid water. Here's the problem. Why can't you have liquid water on Venus? It's too hot. Yeah, it's 900 Fahrenheit or some odd. So, it's too hot, but that's on the surface. And people have thought for a long time that perhaps the clouds of Venus, which are much cooler, could harbor life. As Porpoise points out in Twitch chat, those living things would also have to have some way of dealing with the incredibly acidic conditions. We know life on Earth can tolerate strong acid, but we don't think life could tolerate acid that's that strong. But there are chemical ways to do that. So people have been proposing life on Venus for a while. Not finding, but saying, okay, here's what it would look like. And people have proposed a life cycle where bacteria up in the upper cloud tops, where it's cool enough that liquid water can exist, metabolize, reproduce, extract energy from the chemistry around them. We already have a sulfur-based metabolic cycle among some bacteria on Earth. We know that can happen. But those droplets of water don't stay intact forever. They eventually drift downward. And as they drift downward, they heat up and dry up. And that means those bacteria would lose all of their water. They would shrivel up, they would dry out, and stop being alive. But there are lots of bacteria on Earth that can do things like this too. You dry them out, they're not alive anymore. Their metabolism stops, but if you ever get them wet again, they just start up again. We know that can happen. So people have proposed a life cycle on Venus where things go into the upper, cooler parts of the atmosphere and live and reproduce, and then come back down and dry out and die, and then something about the Venusian weather would take them back up, and they get wet again, and then they live again. So that's a life cycle that people have thought about. But what's the deal with phosphine? So Yami points out that lungfish are something like that on Earth. I don't know how much water they can lose. There are a lot of organisms on Earth that can lose a large portion of their water, like lungfish. But the many desert animals can do that, animals and plants. But some very small things, like bacteria, can lose essentially all of their water and still be alive. But so what happened recently on Venus? Well, we detected this gas, phosphine, in the upper atmosphere that on Earth is always associated with living things. Doesn't mean there isn't other chemistry that could produce it. We don't understand the chemistry of crazy sulfuric acid as well as we do solutions in water. But we found this gas. So the last thing I want to talk about is, how did we detect this phosphine? Does anybody know? Venus is just a little dot in the sky. How do you look at it? How do you go out at night and you see it? But how do you know what kinds of gas it has in its atmosphere? A telescope and science are the two answers. We have educational purposes in Twitch chat says spectroscopy. So spectroscopy is something we're going to study for like 4 weeks later in the semester. It's kind of a shame that this happened now, because the stuff that happened on Venus is basically exactly what we're doing in a few weeks. But it turns out that all atoms and molecules are associated with very particular colors of light. Very particular wavelengths of light. Wavelength and color are the same. And if you take the light coming from Venus and you spread it out in a rainbow, you will see colors that are brighter than others and colors that are darker than others in that rainbow. And those colors correspond to particular molecules and particular atoms. And what happened was, people doing this to Venus, this process is called spectroscopy, saw a dark band, a single very particular color that's associated with phosphine that was darker than you would expect. Darker than the neighboring colors. And they said, aha! Oh, that marker is phosphine. And now the question is, how did it get there? And people were saying, maybe bacteria. Well, that would be pretty fantastic. That would be, in my mind, the greatest scientific discovery in history, to know that there were bacteria on another planet. That is not necessarily what happened, right? We don't know that for sure. That's not even at this point, I would say, likely. But it is a really strong suggestion that somebody ought to take another look at what's going on in Venus's atmosphere. I haven't read all the papers. I've been doing other things in the last 2 days since this came out. But it is extraordinarily exciting, and it's a new direction for planetary science. Yummy asked, this is why Hubble's images are black and white. Yeah, because there are way more colors than our eyeballs can see, right? My eyeballs can see 3 different colors, red, green, and blue. And all of the colors, when I think I'm seeing more colors than that, but they're really mixtures. So the orange in this hat just means that the light coming from this yarn is stimulating the red receptors in my eyeballs a lot, and the green receptors a little bit. And when I'm looking at the computer monitor in front of me, it's all made of red, green, and blue pixels. So our eyeballs are really not so good at color, but our instruments are. So what that means is when we take a picture with a telescope, we have to think very carefully about how we're going to translate the super colorful world that really exists into the 3 piddly little colors that human eyeballs can see. So often, images captured by telescopes are in what's called false color, where we'll take the super colorful world and map it to red, green, and blue, just so human eyeballs can see something. Sometimes we do it in a way that matches what the human eye would see. But sometimes we want to see colors other than the ones that human eyeballs are sensitive to. Any other questions people want to ask about this exciting stuff from Venus? Yes, you're supposed to be seeing the green screen because I'm not talking about anything on my slides. I didn't have slides prepared for this, and I didn't have time to make a bunch of slides about what was going on Venus. So I'm walking around in front of a green screen, and the slides will return momentarily. Any other questions? While you're thinking of your other questions, I'm going to push the buttons on my computer that make the green go away. Boop. There we go. All right, so I have 2 things I'd like to talk about today. One of them involves a doodle on the board involving the moon. And this is something you'll need for this week's lab. Actually, there's a question that just came up in Twitch chat about travel, interplanetary travel. Dr. Piggy Buns, best name, says, this doesn't actually change how we proceed in intersolar, I think they mean interplanetary travel, like we're still set for Mars. Venus having forms of life doesn't mean much for us, and that's a really good point. What does it mean for us that there might be bacteria in the atmosphere of Venus? Well, it certainly doesn't mean we can live there, right? Venus is incredibly inhospitable to humans because of the pressure, the acid, and the temperature. So if humans want to go elsewhere, Mars is our next stop, most likely. But what does it mean? Remember, our class is titled Our Place in the Universe, and that title is kind of ambiguous about what it means. So what does it mean for who we are and how we see ourselves that there are bacteria in the atmospheres, or that there might be bacteria in the atmospheres of Venus? Porpoise says it means our search for other life would have to include Venus-like planets in other solar systems. Kirsten says it would confirm for the first time that we're not the only planet that supports life. That would be amazing to know. Once could be a fluke, right? We could have, if life was a 1 in a billion thing, maybe we're just the only planet that had it. We got lucky and we're here, and there aren't any others. But if both Earth and our closest neighbor, which has very, very different climate, both support life, then that is a really strong sign that life is way more common, right? If it's us and our next door neighbor, then it's probably also the moons of Jupiter and Saturn. It's probably also, well, perhaps moons beyond that. But when you look up at the stars, almost every one of those stars has planets. Planets are very, very common. When I grew up, we didn't know that. I remember reading, as a child, a book on space science saying planets are unique. Planets are rare, solar systems are uncommon, but that's not what we know now. Now we know that planets are common. So if both Earth and Venus have life, then imagine how many other bacteria there are up there, and maybe things beyond bacteria. Yami mentions the possibility of having a submarine to explore below the surface of Europa. There are many worlds with subsurface oceans in orbit around Jupiter and Saturn. I'm going to talk about one in Enceladus at the end of class. Before this thing about Venus, and maybe even after, the oceans beneath the surfaces of the moons of Saturn are what I think probably the greatest likelihood of finding life is. So I want to talk about the moon for a bit. Emma asks, there are lots of great questions about spaceflight. So we have like an entire unit on spaceflight at the end of this class, and I'm happy to talk about these things now, but I'm glad everybody's like into talking about spaceflight, because that's how we end our semester. What's the farthest we've sent spacecraft? To the edge of the solar system. They're still going. They will reach the stars hundreds of thousands of years from now, the other stars. But for now, they're at the edge of the solar system. I think right now, like around 200 AU, I think is their current distance. All right, I really do want to talk about the moon. So, because this is something you'll need for a lab. So here's a question. When the full moon is high in the sky, what time of day is it? Midnight. How do you know that, Erica? You're right, but how did you come up with midnight? It's opposite the sun at full moon. So what you mean is that during a full moon, the moon is on the opposite side of us from the sun. And Porpoise in Twitch chat has the same logic. So I would like to represent that in a diagram, and then we're going to figure out a bunch of other stuff about the moon, like what phase of the moon do you see during the day? So we talked, when we did the moon last week, we talked about what causes the phases of the moon, but we didn't talk about how they relate to night and day. So I want to do that now. I have to push that button, and then I have to push that button. Oh, forgive me, I still had stuff from last period up on the blackboard. So, as before, to make my diagram, I need to know which side the sun is on. And I need an Earth. Here's our Earth. So we're looking down on the Earth from above the North Pole, and I need the orbit of the moon. So here is the moon's path around the Earth. There we go. So what people have been saying is that the full moon is opposite the sun. So here, this side of the Earth is lit by the sun, so the key is white chalk is what's lit by the sun, and I will use pink chalk for what is visible from Earth. And green chalk will be both. So here, this face of the moon it's the same for all of those, right? That's why we see the full moon here. Now, the next thing we need to think about is time of day. This is the new thing we didn't do last week. So I'm going to use yellow chalk to be the observer. Just going to put lots of dots on the surface of the Earth. So the question was, at what time of day is the full moon highest in the sky? So which one of these has the full moon highest in the sky? Well, that one, right? It's under the moon. So what time of day is this? Well, it's midnight. That's the one away from the sun. That's what you all told me. So we'll mark that as midnight, 12 a.m. Okay, let's label the others. Which one is noon? The one on the opposite side, yeah. And that's the one under the sun. All right. What about this one right here, the one on top? What time of day is that? Remember that the Earth rotates counterclockwise. So what time of day is this one? 6 a.m., yeah? And I can fill in all the rest. So the next question I asked was, what moon phase can you mostly see during the day? So that's a full moon. The new moon is mostly visible in the day. All right? So the new moon is this one. I'm going to draw them small over here. So this side's lit by Earth, or lit by the sun. This side is the one facing Earth, but none of it is actually shining. So it's kind of a trick question in that, yes, the new moon is the one that during the daytime is on the daytime side of Earth, but can you see the new moon? It's kind of a trick. Yes, it's the one in the sky during the day, but you can't see it. As Porpoise said in Twitch chat, the part you can see is not lit. Mark the lit side of Earth while I'm here. So of the sorts of the moon phases that actually shine, which one is the most visible during the day? Yeah, crescent moons, the ones that where there's something to see, but they're in the sky during the daytime. So let's draw a crescent moon here. So here's the moon. Here is the side lit by the side lit by the sun is right here. And I need to find the side that's lit by the Earth, or that's facing the Earth. So this part is what's facing the Earth, and the part that glows for us, the part of the moon that shines, and that's facing us, is only here. So that's the part of the moon we can see. So this is a crescent. So what I want to do now is talk about the rising and setting times of these different phases. So let's go one at a time. Let's talk about first the full moon and then the crescent. So for the full moon, we set its highest in the sky at midnight. When does it set? So it's high in the midnight. At midnight, when would it set? Like 7 a.m., a Whitman student, that's their Twitch handle, says when the sun rises. Porpoise has said it depends on latitude. We're going to pretend we're on the equator here just because trying to think about this being tilted would be real hard. These are approximations. So here's my horizon again, right? My apologies that it's a bit overexposed from the lights. So remember that I can place my horizon anywhere I want on Earth to show what that observer would see. So if I want to see what you would see at midnight, I can put my horizon here. So I am the 12 a.m. dot. The horizon blocks off the things below the ground, and the full moon is right over my head. And as seen from the North Pole, Earth rotates counterclockwise. So I just rotate. Need to get a smaller horizon. I just rotate until boop, the moon sets. Notice the moon is setting at 6 a.m., which is what people said. So I'll ask you all this question. So this crescent moon, so this is a waning crescent. Label that because it's getting to be new. So when does this moon rise? This one's a little bit more tricky, but I want you all to think about it. We're going to take some time on this. Tell me when the waning crescent rises. Okay, 3 a.m., 2 dots over. We're using the dots. So let's figure it out. Luke has said 3 a.m. Henshi has said 3 a.m. in Twitch chat. We have 2 people who agree, but I want to figure it out for myself. So I'm going to pick up my horizon again. And I'm going to, as before, rotate it. So here's my horizon. It's now 9 p.m. It's now midnight. Full moon is highest in the sky. Go a little bit more. And now, bam. There's the waning crescent, low on the eastern horizon. So you can use a diagram, a piece of paper to be your horizon. and your brain to figure all of these things out. And you'll be drawing diagrams like that for the lab this week. So I'm going to finish up with the moon here, and now I want to talk about time. That was a hard question, so now let's go to an easy question. What is a day? Let me get much simpler than that. Tell me what a day is. 24 hours, okay. You can't say that because an hour is just a 24th of a day. So tell me what a day is without reference to subdivisions of a day. One rotation. So we have, so Ethan in Zoom, Henchi in Twitch have said, Henchi and Porpoise and LMCG and Myra Wong and Dr. Piggy Buns and Witness Student, a bunch of people are saying one rotation of the Earth. Luke has said one rotation of the Earth, which is also correct. Okay, this hat's getting annoying. Okay, so tell me what a year is. We figured out a day is a rotation of the Earth. What is a year? One revolution of the Earth around the sun. Okay. So I'm going to switch back to my slides now. People have told me these things. I got to do my green bit. People were, so what you see on your slides, people actually told me to type last time. Last time I asked the class these questions and I added them to my slides in real time. I didn't have a chance to reset that, so the slides still say this stuff. You can't see the slides because I need to push that button. Okay, what's a month? Porpoise, that's where we're going. A month is one orbit of the moon. Yeah, so it's, so Kirsten, you say it's supposed to reflect that. It doesn't do the best job, but yes, it's supposed to be close. So I'm going to call it a moonth, in part to be funny, but also to remind us that that's where that word comes from. So these are our three basic cycles that we see in the sky. And this is what you all have told me about what they are. But I want to look at the day a little bit harder. So tell me which one of these is the day. Is it how long it takes Earth to rotate once? Or is it the amount of time from noon to noon? And Porpoise asks the really good question, what's the difference? Right? If those are the same thing, then why am I even bothering to ask this question? How is it that those are different? Kirsten says it was defined as the first one, but now it's 24 hours. So let's actually look at how these two statements are different. And to do that, I'm going to need another diagram. So we'll go back to my board. I need to make a hotkey that turns on and off green screen processing, don't I? All right. So we're back to the board. We're going to forget the moon for now and draw just the Earth and the Sun and an observer on Earth. So what do I need? I need a sun. I promise it exists, even though we don't see it in Syracuse very often. I need the orbit of the Earth around it. I need to pitch the camera up slightly. So, suppose Earth is here, and suppose this is, we'll say this is January 1st. Now, if I put my observer here, actually we'll put them on the other side. If I put my observer here, what time of day is that person experiencing? Midnight, okay? So you might imagine that if I just, like, what will happen to this person as time passes, right? They're going to do this. They're going to rotate around as days pass, and they're going to revolve around the sun as the year passes. I know that we'll talk about the zodiac as well. Oh, can't see that. I don't have enough board for that. I'll do this in another diagram. So what I want you to do is to think about, say, 180 days later. So tell me what this picture will be like 180 days from now. While you're typing that, I'm going to adjust some things on my camera. It's now gotten a lot darker. And now it's gotten brighter, but now we have more things in focus. So 180 days from now, where do I draw the Earth? "90 degrees counterclockwise, so right over here, right? So this is 180 days later. So I want to read a couple of things from Twitch chat. Porpoise says, "I think I see the point. It takes a little longer than 24 hours to be facing directly away from the sun because the Earth has moved slightly. 180 days would be noon." And Dr. Piggy Buns has said the same thing. It would be noon. So 180 rotations of Earth later, we need to be specific here. So 180 rotations later, if I rotate exactly 180 times, I'm on the same side, right? That is noon. Whoops! So a day can't be, or at least a day is weird, if it is a rotation of the Earth. Okay, what happened? Do I want to define a day so that 180 days later gets me to noon from midnight? Is this really what we do? Or do we do something else? So there's a comment about 5 extras in a year because the year is really 360 days, or 365. This would work the same way if it were 360 exactly. So Picky Buns is still saying, let's define the day as the rotation of the Earth. Stick to my guns, right? If a day is a rotation of the Earth, this means that, like, sometimes at the beginning of the day it will be sunny, and sometimes at the beginning of the day it will be nighttime. That's really confusing, right? If 12 a.m. is sometimes bright daylight, and sometimes 12 a.m. is the middle of the night. So here's the solution to this quandary. We have two different kinds of day. Because we know that the kind of day we really use, the calendar we really use, let me color code this. So this is 180 rotations later. And this is what we would get 180 calendar days later. So the trick here, right, I asked you what a day was. Is it noon to noon, or is it one rotation of the Earth? And the answer here is that they're different. That's the surprise, right? Because we see that if I wait for 180 calendar days, I've got to rotate 180 times and then half again. So that's the catch. I'm poking some stuff on the computer. Give me 1 minute here. We're about to come back to the slides. So the trick is, we've got two kinds of day. One of them lined up with the rotation of the Earth, and one of them lined up with the sun. We're okay. We're back now. So I can either measure the day by the sun and say, well, it's noon on one day to noon on the next day, or I can measure the day by the stars. This is called a sidereal day, after sider, which is the word for star. So if Earth rotates exactly 360 degrees, then the stars will come back to where they are. Kirsten, I'm going to come back to leap years in a minute. So which one of these kinds of day is the one that is on our calendar and that matters more for our lives? The solar day, yeah. Because it is always, like at 12 o'clock a.m., it is always nighttime, unless you're above the Arctic Circle. And at 12 p.m., it is always daytime. So the solar day matters more in our lives, so that's what we've got our calendar set up for, and that's 24 hours. So even though the sidereal day is this nice, like, simple 360 degrees around, the solar day is the one that matters more for humans, and thus that's the one we tell time by. So, as people have been saying in Twitch chat, you have to think about the Earth's motion around the sun. So one solar day, the Earth rotates 360 degrees and then a little bit more. I'm not going to show you this animation here for the interest of time, but in our world, what this means is that every day the Earth moves about 1 degree around the sun. So in one solar day, the Earth has to turn 360 degrees around, and then 1 more degree to compensate for the fact that we moved. In my drawing, I did 180 days at once, but this is a description for what happens day at a time. Okay, so this is the difference here. The difference is 4 minutes. 4 minutes is 1/360th of a day. So we've talked about the day. Now let's talk about the month. So when we say a month, one lunar cycle, do we mean to go by the moon's phases, or do we mean to go by the moon's orbit? Which one do you think matters more? Pamela says the orbit. Twitch chat, the phases. Ah, same thing in it is the comment. Porpoises says it's the phases. So let's see why they're not quite the same thing. We'll go back to the blackboard. Not going to bother pushing all the buttons this time. I just won't use green chalk. I'll make that faster in the future. So as before, to understand the moon, I need the direction of sunlight. Can't use that color chalk. I need sunlight. I need an Earth. Actually, I need a lot of things. Sorry. That's not exactly what I wanted to do. Back up. I need the sun, the actual place where the sun is. I need the Earth's orbit. And I need to draw the moon, so I need to draw a lot of things. So the Earth is here. And here's the moon's orbit. So in the moon's orbit here, where is the full moon? Where in this orbit is the moon full? Yeah, the furthest from the sun. And we know that this rotates around 1 month. Okay, so where will Earth be about 1 month later? 3 o'clock, yeah. So 1 month later, the Earth will go to here, and here is the lunar orbit, right? Because in 1 month, the Earth rotates 1/12 of the way around. So in this lunar orbit, where is the full moon? This is the key point. Where do I put the full moon now? At 23 degrees up, yeah, like. So the full moon, this is the key point, is now at this spot. So in that period, right, in that full cycle of phases, Yeah, Porpoise has said this is the same as the solar and sidereal day. We've got a sidereal period for the moon and it's called the synodic period. You don't need to know that word. But in this time, the moon has gone around its orbit once, and then a little bit more. So the catch is that we now have two different kinds of month as well. We've got the one that's the cycle of phases, and we've got the one that's one orbit. So this one, running out of colors I'm allowed to use that are not green, that's one orbit later. Porpoise has made another point that we don't have, that the year isn't evenly divisible by the length of a month. So that's coming. Let me catch up. I'm actually going to flip back to my slides in just a second. Which I can do, I believe, just by doing that, and then by making myself smaller. Whoops. There we go. So here's the problem then. We've got two different kinds of month. The only one that we're going to talk about are the phases. The 29.5 day month. That's full moon to full moon, new moon to new moon. If you care about the moon lining up with the stars, so the sidereal month, then that's 27 days. But that's really not all that interesting. Yes, the slides are available. Go to the course website. They should be linked from the main page. If they're not, then I messed something up and I'll fix it right after class. So what about the year? So we've realized that the length of a day and the length of a year, or excuse me, the length of a day and the length of a month get a bit complicated because of the Earth's motion around the sun. Does this happen for the year? Do I measure a year by the seasons? So from solstice to solstice, or do I measure a year by our orbits around the sun? I'll let you all ponder that one and type. Kirsten is doing what a good scientist would do and saying, wait a minute, we have empirical evidence that stuff's weird, right? Kirsten has said, let me kind of add a little more detail to that. She has said that, okay, I know that the constellation behind the sun at the winter solstice is not always the same, right? So there's definitely got to be a difference because our experience with our astrological signs being off tells us they're not the same. But the question is, what's got to happen for them to be different? Porpoise has said something about leap years. This is actually not the origin of leap years. The leap year is something more mundane, which we'll talk about in a moment. The leap year is just that a solar year, a seasonal year, is not 365 days and it's not 366 days. It's somewhere in between. So the length of the year is 365 and a quarter, more or less. So we've got to add a quarter of a day a year. And we do this by adding one day every 4 years. But they've said that the Romans had a different problem. It's actually not 365 and a quarter. It's 365.24. So what the problem the Romans had was that if you're adding a leap day every 4 years, you're actually adding too many leap days. So the Romans realized after a long time, right after everything got off, that, oh, we've got to add fewer leap days than that. So it turns out it's a leap day every 4 years, but not every 100 years. And that gets pretty close. So I want to, I need to click a few more things. Give me one moment here. I want to show you something different. Now I need to push this button and then this button. So you can now see a diagram of how we understand our year, right? Yes, Porpoise, but yes, there is every 400 years that one is added. So 1600 and 2000 are leap years. So here is how we understand the motion of Earth. I am very small, so you'll just have to look at my mouse cursor. The Earth goes around the sun. The constellations in the zodiac are arranged in a ring around the orbit of the Earth. And so, for instance, where we are now, the fall equinox, Leo is behind the sun. December 21st, on the winter solstice, Earth's axis is tilted away from the sun and Sagittarius is behind. So now with this diagram, I get to the question, what would we have to change for the changing of the seasons to be different from the motion around the sun? What would have to go weird? And while you all are thinking about this, I want to doodle on the board, ready to draw on the board. I'm going to reproduce this diagram on the board, and then we're going to add stuff to it. I need the sun. I need the Earth's orbit around the sun. And I need to draw in the zodiac. So Luke says that something would have to happen with Earth's tilt. Henshey says our days would have to fail to sync up with the solstices. And Minute Hand says something would have to change with our tilt on the axis. So what would have to change about Earth's tilt? The amount? Let's see. So I'm now going to label the zodiac just like it is on the computer display. So I'm drawing the layout of these actual physical stars. They're far off of the screen, of course. Scorpius. Sagittarius. I'm not going to write all of that out. Aquarius is that way. And, oh, forgot Capricorn. Okay, so now I'm going to switch to that display for realsies so you can see it. So all that you're getting here is a Blackboard version of what we've got. So what people are talking about in Twitch chat while I was drawing is that if Earth's tilt changed, the location of the solstices would move. So let's label in Earth's tilt. So we'll start on the winter solstice. And I'm going to draw in green chalk, drawing white chalk. In white chalk, I'm going to draw the Earth's tilt axis away from the sun. We're looking at the arrow coming out of the North Pole. So okay, so in our little diagram, what month is this picture of Earth? Remember, this is the axis of Earth's tilt. So here Earth is tilted away from the sun, here Earth is tilted toward the sun. December, okay. We'll just write down season names. This is winter. What about this one? Spring, yep. What about this one? Summer. And this one is fall. So now here's the catch. The axis of Earth's tilt changes very slowly. The issue is that this goes around every 26,000 years. So that means that's slow. So here we are right now. We're set up like this. But in the past, let's see, yes, in the past, we were set up like this, and now Earth's axis, or in the future, let's say 7,000 years in the future, will be like this. This is precession. Yes, exactly. The word precess just means to change your axis of rotation. So, let's do this. Let's move 7,000 years in the future. All right? So 7,000 years in the future, it looks like this. So, what changes? Do the seasons change? Do I have to erase all of this text and write new seasons in? Yes, I do. So, this one is now winter. This one is now spring. This one is now summer. And this one is now fall. When that happens, I've also got to change the months on the calendar. Please indulge me for one more minute. Well, actually, no. We'll pick it up next time. But this is why. So someone has said, this is the closing thought, the time of the year they happen changes. So this depends by what you mean by year. The place in the orbit they happen changes. The astrological sign they line up with, the constellations in the sky change. But it depends what you mean by year. And yes, thank you. See you all later. We're over time now. I'm just answering questions. But yeah, as Porpoise says, the times of ancient Greece would have been off by about 10% or off by one zodiac constellation. And that's why your horoscope is wrong. We will pick this up again next time. Sorry I missed the timing a little bit, but we had to talk about cool stuff on Venus. So I'm going to go right now up to the steps of Hendricks Chapel if anybody wants to chat. We will pick this up on Thursday. Sorry we were a little scattered, but we really had to talk about the phosphine because it's super cool. Thank you, Marvelum, LMCG. Kirsten, shoot me an email. It's not something I want to say on stream, but shoot me an email. Thanks, Scarlett.
Professor Freeman?
Yep.
I just had a quick question. So when I originally asked to form my group, I think I accidentally submitted the wrong lab time and hence I'm in the wrong group. And so when I went to my actual lab that is shown on my schedule, I'm now a part of that lab group, but my Monday lab group, I want to exit that and not be a part of that lab group.
Okay. I'm very I'm sort of confused. If you could you sent me a bunch of mail about groups. If you could send me one message telling me what time you want to go to lab, I will get you in a group at that time, okay?
I'm already in a group in that lab, but I just want you to take me out of the other group.
Okay, if you could send me a message telling me what time you want to go to lab, I will make sure everything is set up great. I haven't rerun my group script, but you will see that in just a minute when I rerun it for groups for Project 2. Kirsten, they both go the same place. So yeah, Aryan, just tell me what you want and I'll get it all set up for you.
Thank you.
Yeah, Kirsten, so the reason that stuff from me comes from g.syr.edu is because they all forward to my g.syr.edu because Exchange is crap and Gmail works pretty well. But it doesn't matter which one you use. They all go the same place. Porpoise, you've raised a really good point, which is a lot of our holidays matter with the seasons, right? So Henji has said, why change the months and not just start associating August with winter? That's what we did. We did that for 1,500 years. Like the winter solstice was in March for a while, but then everybody was getting really confused, and like Christmas was in the fall, and as Porpoise has said, and if your festivals, if the things on your calendar have to happen in certain seasons for them to make sense, you want to line your calendar up with the seasons. So this is a really, really important thing with how we design calendars. And that's what your first paper will be on, and we're going to talk about that on Thursday. So you're asking the great questions. I'm going to kill the recording here, and I will catch you all out either over by Hendricks or someplace else.